Hi, I'm Jack Richens, and I'm presenting SQL Server 2012 Security Enhancements today. We'll be going over and reviewing features that were introduced in SQL Server 2008 to set the context, and then reviewing new features that are being introduced in SQL Server 2012. Along the way, you'll learn how you can use these features to better reach compliance in SQL Server 2012. Let's start off with going over a recap of the 2008 features and then the new features in SQL Server 2012, namely manageability enhancements, audit enhancements, database authentication, and cryptography changes for SQL Server 2012. In SQL Server 2008, we had a very strong suite of security features that addressed areas in protecting your data, controlling access, and ensuring compliance across your SQL Server deployments, with features such as transparent data encryption, extensible key management to help protect your data at rest, Kerberos authentication enhancements to improve the security as you were logging in and authenticating with the system, and SQL Server Audit and change data capture, policy-based management, and common criteria certification to help you reach compliance. This provided a strong security story for SQL Server 2008 as we provided you means to monitor access to your data and control access and reach compliance through features such as transparent data encryption, auditing, and monitoring whether those features were on or off through policy-based management. We allowed you to greater control over your key management through extensible key management. And audit and authorization provided granular control over who had access and an audit log of who was exercising that access. Login triggers and SSL further protected the connections of applications to the SQL Server data stores. And remote backup allowed compliance and risk management of protecting your data assets. So let's talk about what's new in security in SQL Server 2012. We've improved manageability of security in SQL Server 2012 with features such as default schema for groups and user-defined server roles. Default schemas for groups is a new feature in 2012 and a long-standing ask in Connect for SQL Server. Previously, you could only define a default schema for an individual user. Now you can assign a default schema to a group. This eases administration and avoids implicit schema creation and implicit user creation. It reduces the chances of the wrong schema being used in queries and reduces the number of users that need to be maintained and monitored. We've also introduced user-defined server roles. A server role is a server-level principal, kind of like a server group that the administrator can define. It's a collection of principals that hold a collection of permissions. This can be compared to fixed server roles, where it's a securable class and the permissions can change, so you can have different permissions that match your compliance needs. It increases the flexibility and manageability and facilitates compliance. Previously, we had database roles, and these are much the same. It allows customers to define a role, grant it permissions such as control server, and deny it other permissions such as alter any login. Let's demonstrate that now. Here, I'm connected to SQL Server 2012. I'm going to create a new server role called XE-admins. This role is intended to provide a means of administering X events, a new feature in SQL Server 2008 and one that's been greatly enhanced in 2012. So let's create that role and grant it alter any event session and view server state so that it can both monitor the system and create event sessions. Now I'm going to create a login to demonstrate using this. I'm going to add that login to the role. with the alter server role DDL statement. Now I'm going to switch and use the UI. If you look over under the database node, under management, there's a UI now around extended events. I'm going to expand that and so that there's a couple of sessions there. Right now I'm connected as Redmond/Jack R, an administrator on the box. But I can create a new database connection as the user I just defined, Bob. So let's connect using Bob and let's see what he can do. If I go under the security and try and do something like create a new login, which Bob lacks the authorization for, I'll get the UI. But if I try and click OK, I will get an error saying that I do not have permission to do this. However, if I go under the Management tab and go down to Extended Events, we'll find that I can start and stop sessions. I can create new sessions. I can use a template using the UI, add any events that are interesting. Determine which data I want to collect. Review and add any filtering to these fields that I want. Determine how I want to collect the information. And then have it go and create it. I can even view the data that's being collected in this nice UI. So let's stop that and drop that session. So I've just demonstrated that I can use flexible server roles to define a role that has a constrained set of capabilities, in this case administer X events. And I was able to add my own user to that account, and that user was now able to administer X events. We also paid a lot of attention to audit in SQL Server 2012, adding support for all SKUs, improved resilience for the audit log, user-defined audit events, and recording and record filtering. We also record T-SQL stack information for repudiation of the audit log events. Audit is now available on all SKUs. The basic core audit functionality includes server audit specifications. This is available only on, the server audit specifications are available on all SKUs, but we reserve the database audit specs, which include the granular audit capabilities for enterprise and data center. This means that you no longer need to depend on SQL Trace across your enterprise. You can enjoy the basic advantages of audit across all of your SKUs from Express through Enterprise, which include performance, multiple audit targets, persistent state, and audit resilience of the audit logs. In SQL Server 2008, we only had two options for handling errors when writing to the audit logs. One was to ignore the errors. This could result in silently losing audit records. The other option was to shut down the entire SQL Server instance on the first encounter of an audit log error. This hurt availability. This forced customers to make bad compromises. Now we've improved our ability to self-recover from many file and network errors, and we've added a new option to handle failures for the audit log. And we've also added max files options to better control usage of the audit logs. So let's discuss how this new failure operation mode. Let's say the customer performs a select and we attempt to write that to an audit log. We encounter an error. What will happen now is that we will roll back the select transaction so that the audited operation does not take place, but other operations that do not require auditing are allowed to proceed. This provides maximum availability along with maximum assurance that all required events are being recorded in the audit log. We have also included T-SQL stack information. Let's say a customer is executing a stored procedure, such as view salary. Inside that, it goes and does a select from the payroll table. In the audit log, when we audit the select on the payroll information, we will see that this is not an ad hoc select from payroll, but indeed a call from the stored procedure. This provides you guarantees that access was done through not directly, but is being done through business logic encapsulated in your stored procedures. We've also added user-defined audit events. This allows customers to provide their own audit events that express information in their business logic. An example of this is you can define your own audit event number for your own filtering and record keeping, a success or failure bit, and then any arbitrary string to express the business logic of what this audit event represents. So the first parameter is the event ID. This is user-defined, the success bit, and then the user-defined information. We also record the date and time. It will all show up underneath the same action ID, but you can filter it using the user-defined event ID. We've also added record filtering to SQL Server Audit. This tightly constrains the information that's written to the audit log. The audit record is generated, but it's not written. So in this respect, it's not as performant as the granular audit filtering in the database audit spec, but it is more expressive in that you can filter on any column in the audit record, and is very performant as it leverages X-event filtering. Let's demonstrate some of these enhancements, namely the user-defined audit event. For this demonstration, I'm going to be creating a user-defined authentication, meaning that we have a middle tier that's connecting to the back end directly using a service account, but then it passes in a username and password hash, which we compare against a table inside the database engine. So this is application level authentication. As part of this, I'm going to be storing an audit record in the back end in my SQL Server database audit that records the result of that authentication. So let's create the database. Let's create the database, use that database, create a schema for the application. Now I'm creating the accounts table inside that schema and inserting 2 users into that accounts table. Here I have a stored procedure that establishes the application level identity. I pass in the name and the password hash that's generated at the client layer. Then I will check the table using a select statement to see if that name exists. I'll set the result of the compare, and then I will write a user-defined audit event that gives the result of that. Now let's go and configure an audit to capture this information. So I go to the security node, down to audits. I already have an audit set up. Let's review its configuration. This is just a basic audit, no filters defined on this, and it's going to go to this file target. Let's turn that on. And I have a server audit specification here. Let's see how that's configured. Right now it's auditing authentication at the database level and logouts, and I'm auditing this new user-defined audit group. Let's enable that. Now let's do a test authentication. Here I'm emulating the application trying to connect, and I successfully connect there. Now I'm going to do a failed connection, and I get back a 0 there. If we go and look at the audit log, we can see these events here. You see the user-defined audit event. If we come over here, you can see the new fields here. Here's the T-SQL stack information, which lets me know that this was not an ad hoc user-defined audit event, but indeed went through my stored procedure for establishing identity. And we can see the user-defined event IDs and the information from that stored procedure that's user-defined, namely the name of the web user that tried to authenticate. We can also see the success result. One succeeded and one failed. So that's user-defined auditing. Let's take a look at audit filtering. Here I'm going to go back to master. I'm going to look up at my own principal ID. A common request is to either filter so the audits do not show sysadmin activity, or they only show sysadmin activity. In this case, I'm going to create an audit event or an audit filter so that my actions are ignored and do not show up as part of the audit log. Here I'm going to create a server audit, and as part of it I define a filter where the server principal ID does not match my own. I'm going to turn this audit on. Now I'm going to create a audit specification so that I capture all failed login events, successful logins, logouts, and user-defined audit events. Now if I create a new query, logging in as myself, what we will see in the audit log that has been filtered is no events. However, if I change my connection and log in as a different user, we will see activity from that account. So this is an example of SQL Server 2012 audit filtering. As I said before, these filters can be defined on any field in the audit log, and I think this is a feature that you will find quite useful. Let's discuss database authentication now. This is new with contained databases, and it was a feature that was designed not only for contained databases, but for use with always on. This allows authentication without logins. You can do this either with SQL users with passwords or Windows authentication without a login. This makes it easier for deployment for contained applications and a tightly scoped security boundary where you're giving no more access than is absolutely necessary. With a SQL user, with a username and password, the connection string provides a username and a password and an initial catalog. If you name an initial catalog that's just a normal database, you get a traditional login. If you name a contained database and a user with that name exists, we will always attempt to do a contained user authentication. If a user exists with that name but a different password, it will fail. If there is no user with that name, we will fall back to master and check to see if there's a login there. We did this to provide maximum backwards compatibility for as many customer scenarios at all, so that there's minimum impact to connection strings for your existing applications. With Windows users, if you name a normal database as the initial catalog, you continue to get a full login. If a login exists, you will get all the permissions of that login, even if you name an initial catalog that is a contained database. However, if there is no login, but there is a user in the contained database, then you will get a contained user token. So let's do a quick demonstration of SQL Server contained database authentication. I've already on this database instance, or this SQL Server instance, enabled contained database authentication. It is off by default so that people don't have to be concerned about a security environment changing on them just by mere fact of upgrading. But in this case, I want contained database authentication, so I've enabled it on the server under advanced properties under this containment enable contained databases. So that's already been set. Now I'm going to create a contained database with partial containment. I'm going to use to that database and create an account for a local Windows group. I'm going to add this Windows group to a couple of database roles, create a schema for it, and set the default schema for this Windows group. I'll create a table in that schema and insert a few values into it. Now let's go back to master here for a second, and now I'm going to log in as a contained user that's a member of that Windows group. So as you can see, I'm now logged in as a contained user, Bob, into CDB1. I cannot see other databases. I only have access to this one database. But within that database, I can attempt several things. I can try and execute system procedures, and anything that's allowed to public users I'm allowed to do, but I cannot, for example, change settings. If I try and query sessions, all I will see is the accounts I have access to, because I'm a contained user. I can look at the table I have access to, I can insert values, and do everything that was intended. While keeping that connection open, let's look at how you can monitor and manage these accounts. So as an administrator, if I log in and query these accounts, I can see this contained user. If you go all the way over here, we have some new fields in here, authenticating database ID. So I can see which database different connections are in, and I can see where they authenticated. For traditional logins, the authenticating database is always master. For system connections, there's no authentication that happens. These are just system sessions, so they have no authenticating database. Everyone else has master, and contained users will have the database they authenticated against. This information is all available within login triggers. So this gives me a lot of flexibility in controlling and managing contained database authentication. Let's go quickly define a login trigger. I'm going to create a table that allows me to turn on and off different databases. I'm going to grant select to public, but retain write permission to myself. So I'm going to insert master into here. I'm going to create a trigger that's going to check whenever a login tries to take place. It'll check where it's authenticating, and if it's not one of the allowed databases, it will roll back and fail that authentication. Now if we go back to Bob, and if he tries to create a new connection, he will be denied due to trigger execution. That's fine. All I have to do as an administrator is go in and add him to this lookup table and try again, and now I'm in. So that's an example of how you could use triggers to granularly control contained users. One other mechanism that you can do is keep track of who might be able to authenticate. On our team blog, we've documented a stored procedure that would allow you to do this. It's called all authenticatable users. It checks all the server principals and then finds all the contained databases and iterates over each of them and find the user accounts that could be used to authenticate. So let's go ahead and create that, and it's already created here. Now let's execute that stored procedure. And we'll see right now there are several logins on this system. And there's one contained database, and there is one account that can get into that contained database. So this would be a good mechanism to monitor and keep track of all of the accounts that have access to your contained databases and to your SQL Server 2012 instance. So that's SQL Server contained database authentication. We've also made some cryptographic changes to try and keep up with the times and ahead of attackers. For greater flexibility in moving certificates around, we've added DDL to allow you to create certificates from bytes. We've added support for 4K certificates for import. We've changed the default for our service master key and database master keys to AES 256 encryption. We've added key backups support so that they're now encrypted with AES 256. And we've added SHA-2, 256, and 512 support. Password hashes now use SHA-512 by default. This will happen automatically as new passwords are added to SQL Server 2012. And we've deprecated RC4 support. For those of you that would like more information about these enhancements and others, like to refer you to several of these resources on Books Online under SQL Server 2008 Security and SQL Server 2012 Security. Additionally, check out the SQL Server Engine Security blog and the SQL Server Security Forum. Thank you, and I hope you've enjoyed learning about security enhancements in SQL Server 2012.